let's try another one. So here we have the equation x squared times y plus x times y cubed minus 2x equal to 6. And it's a perfectly good equation involving two variables, x and y. But now we want to use implicit differentiation to actually calculate the derivative y prime. So again, we're viewing y as both a variable, but more importantly, we're also viewing y as a function of x. So we don't actually know what the formula for that function is. We don't have y equals, so it's an implicit function. What we do have, though, is this equation. And so all the x's and the y terms are kind of mixed together. So we're going to use implicit differentiation to calculate y prime. And how this starts off, we write down our equation, x squared times y plus x times y cubed minus 2x is equal to 6. And then we go through each of these terms and we just apply the derivative. So I'm going to apply the derivative to that first term, the derivative to that second term, our third term, and then on the right side, I'm going to apply the derivative to everything over there as well. And we're kind of using one of our derivative rules already. We know we can split up the derivative over addition and subtraction, but it doesn't work with products. So we're kind of viewing this whole thing, this whole x squared times y as just one term. Same thing right here with this x times y cubed. Differentiation doesn't work so nicely when we have a product. And so for each of these, that's what we have. We actually have a product. So we have this x squared, it's an x term, and it's times y, which we're also viewing as a function of x. So it's really kind of like two functions of x that we're multiplying here. X squared is a function of x, and we're viewing y as a function of x, and we're multiplying here. So we have to use product rule. So we got to use product rule here, and we got to use product rule here. Because again, there's an x term right here, and then we're also viewing y as a function of x. So we have two functions of x that we're multiplying together. So when we have a product of two functions of x, we have to use product rule. All right, so let's apply the product rule for this first one. And what do we get? So we write down our two copies of our product, x squared times y, x squared times y. And then in the first copy, we apply the derivative to just the first part. And then in the second copy, we apply the derivative to just that second part. And then we put a plus sign in the middle. So that's the kind of the first term here. If we're looking, we're differentiating just that first term with the product rule. Now if we go on and do the second term, how's that going to look? Again, we have to use product rule here because we have a product. So write down two copies of that product, x times y cubed, x times y cubed. In the first copy, we apply the derivative to just the first part. And then in that second copy, we apply the derivative to just the second part. And then we put a plus sign in between because it's product rule. And then we originally had a plus sign there as well, so there's going to be a plus here. So this is our derivative of our second term. And then we just kind of keep going down the line here. So we have this 2x. What's the derivative of 2x? Now this one involves only an x, so we can just differentiate this like usual. So what's the derivative of 2x? Well, it's just 2. And then we had subtraction, so it'll be a minus 2. And then finally, on the right side of our equation, it's just a constant, so derivative of a constant is 0. All right, so there we go. We're kind of getting there. Had to use some product rule. And now we just keep going. So we keep differentiating. But now we've gotten it to a point where these involve only x's or only y's. All right, so let's start with this x squared. There's only an x there, so we just differentiate it like usual. So derivative of x squared is 2x. Then we have a y outside the bracket, so it just stays y. Then we have plus x squared, which is also outside the bracket, so that just stays in x squared. And then we differentiate y. So what's the derivative of y? Well, that's 1 if we differentiate it like usual, but then we multiply by y prime. So differentiate that variable like usual, you get 1, but then multiply by y prime. Or you could just say y prime. And then we go on, keep going. We still have some derivatives to do. So what's the derivative of x? Well, derivative of x is just 1. And then we have a y cubed outside the brackets, so that just stays a y cubed. And again, you don't necessarily have to show multiplication by 1 here. Well, we're just doing it to really emphasize that the derivative of x is 1. Y cubed was outside the brackets, so that stayed the same. Then we have addition. This x is outside the brackets, so that stays the same. And now we have to differentiate this y cubed term. So it's it's only a y. So we differentiate like usual. We get 3y squared. So regular power rule. Y cubed, we get 3y squared. And then we multiply by y prime. So that's kind of the new part here. We're multiplying by y prime. And then we have our minus 2, and this is equal to 0. All right, so you can see we have a lot of terms floating around here. But we are done differentiating. So the last part of this is we want to actually solve for y prime. So we look in our equation, what we have after all our work, and we want to identify the y prime terms. So all the terms that have y prime. So this term doesn't, but this term does. This term doesn't. There's no y prime in here, but this one does. So we want to keep these on the left. And then anything that doesn't have a y prime, we're going to move those to the other side of our equation. So we're going to subtract 2xy from both sides to get it over. We're going to subtract y cubed from both sides to get it over to the other side. And then we have a minus 2, so we want to add 2 to both sides so that we kind of get rid of it on the left. So what do we have then after we've moved everything over? Well, from here we have x squared times y prime. And then from here we have 3x y squared times y prime. And again, it helps to put the constant first, and then kind of go in alphabetical order, and then put your y prime at the very end. And then what do we have on the right side? Well, we have a plus 2, and then we have a minus 2xy and minus y cubed. All right, so far so good. We still want to get y prime by itself. So what we can do next is we can factor out a y prime. Everything on the left now is guaranteed to have a y prime, so we can actually factor that out. So what do we have left over? If we factor out a y prime, what are we going to have left over? Well, we're going to have an x squared left over and a 3xy squared left over. So we're factoring out a y prime here. Nothing's happening on the right. And then finally, we want to solve for y prime. So just take this term in front, that whole thing that all the leftover pieces there, and we're just going to divide both sides by this. So we're just going to take this whole thing and divide both sides of our equation by that. And so when we do that, we're going to have y prime left all by itself there on the left side. We'll have 2 minus 2xy minus y cubed, and then we're going to divide by x squared plus 3xy squared. And so there's our derivative. And sometimes there might be some ways to simplify this, but this is pretty good. So we're going to leave this. So you can see, sometimes it takes a little bit of work to solve for y prime. And so generally the way you want to do this is go through, identify all the terms that have y prime, keep them on the left, and then move everything else that doesn't have it and put it on the right. Then you can factor out a y prime just like we did here. And then you'll have this kind of big complicated piece in front of your y prime, and you just divide by that and get it over to the other side. So you're getting all the y prime, You're getting all the terms of this way that don't have y prime on the right. So when you look at this, there's no y primes here on the right side. All right, but there are x's and y's, so that's perfectly fine. All right, so we calculated y prime. What can we do with it? Well, let's find the equation of our tangent line at the point 3, 1. So we know there's kind of three things we need for a tangent line. There's our x coordinate, there's our y coordinate, and there's our slope. So for this problem, we're actually given the x coordinate, it's 3. We're actually given the y coordinate, it's 1. If we didn't know our y coordinate, we could plug our x value into this equation and solve for y. So sometimes you might have to do that. So sometimes if you're only given the x coordinate, you might have to plug that into the equation and then solve for y. But here we're actually given the x coordinate and the y coordinate, so that's good. How do we find the slope? Well, the slope of our tangent line is the derivative evaluated at this point. So we're going to evaluate it at x equals 3 and y equals 1, because that's the point we're interested in. So let's write in what was the derivative we found. It was 2 minus 2xy minus y cubed all over x squared plus 3xy squared. And let me make sure I got that right. 2 minus 2xy minus y cubed, x squared plus 3xy squared. Yeah, it's the right derivative. So we're just going back to what we calculated for y prime. And we're going to evaluate this when x is equal to 3 and y is equal to 1. So go through the equation. Wherever you have an x, change it to a 3. Wherever you have a y, change it to a 1. So we're going to end up with 2 minus 2 times 3 times 1 minus 1 cubed all over 3 squared plus 3 times 3 times 1 squared. So we've just plugged in x equals 3 and y equals 1. Clean this up. We get 2 minus 6 minus 1 on the top and 9 plus 9 on the bottom. So we end up with negative 5 over 18. So there's the slope of our tangent line. Okay. Well, that's fine, but we want the equation of our tangent line. So we start with our point slope formula. Y minus our y coordinate is equal to the slope times x minus our x coordinate. So this is just our line equation. And then we just fill in the three pieces. So the three ingredients here. So our y coordinate was 1, so we end up with y minus 1. Our slope of our tangent line, negative 5 over 18. So that goes in for m. And then x minus our x coordinate was 3. So we get x minus 3. And then from here, we can just, if we wanted to, we could solve and get it in the form y equals mx plus b. So we can solve this for y to get our equation. But this is fine as well. So if you did get it into that more standard form, you'd have negative 5 over 18 times x and plus 11 over 6. Make sure I did that right. We'd end up with plus 15 over 18 and plus 1. Yeah. Okay. All right, so there's our tangent line. And you can kind of see that in our graph here. So in this graph, we have the curve represented by this equation graphed in, and you can see that there's a lot going on. But we're actually interested right around this point 3 comma 1. And so right around this point, our curve actually is looking like a function, so that's good. And it makes sense to talk about what that tangent line is. So here's our point 3 comma 1, and then we actually found the equation for this tangent line. All right. So just kind of just practicing differentiating these implicitly defined functions. So we'll try a few more. We'll see you there.